Hello everybody. Today we're going to talk about dividing fractions. Before we actually divide fractions, I want to go over another example with multiplying fractions. Why? Because the steps for multiplying fractions and dividing fractions are very similar. There's only maybe one or two additional steps for dividing. So let's look over this example for multiplying fractions. So the first thing you want to do is look to reduce vertically and diagonally. Now vertically would be within each fraction. Diagonally is diagonally, right? So we look within each fraction, 3/5, can't reduce that. Now we look at 10/27, we're not worried about the sign right now. Can't reduce that because our only factors of 10 are 1 and 10 and 2 and 5, and none of those numbers besides 1 go into 27. So now we look to reduce diagonally. So if we look this way at 3 and 27, 3 can go into both of those, right? So 3 divided by 3 is 1. 27 divided by 3 is 9. Now let's look at the other way diagonally. So 5 actually goes into both of these. So 5 divided by 5 is 1. 10 divided by 5 is 2. So we reduced diagonally and vertically. Your second step is to multiply straight across. So that means numerators to numerators, denominators to denominators. Okay? So 1 times 2 is 2. 1 times 9 is 9. Now I'll worry about my sign after I do the multiplying. So I'm just moving this over. So because we are multiplying a positive fraction times a negative fraction, that makes our final answer negative. But we do want to see if we can divide or simplify the final answer. So that's your third step. Divide or simplify completely. So if you look at 2/9, we cannot simplify that. So that is our final answer, negative 2/9. Okay? So that's a good review because now with dividing, there's basically one additional step. Now, depending if you have a mixed number or an integer, there might be an additional step after or before that. But basically, it's the same thing, except you got to flip this second fraction and make it a multiplication problem first. So we have negative 8/9, make it times, and then it becomes negative 36 over 11. So we flip the second fraction, or take the reciprocal of the second fraction, and make it into a multiplication problem. And now we follow the steps right here. So if you want to recopy the steps for dividing and just make another step in front of step 1, which would be flip your second fraction and make the problem multiplication, then you're in good shape. So again, now we're multiplying. We look to reduce diagonally. We can't reduce 8 and 11. We look to reduce 9 and 36, but we can reduce those. 9 goes into both of those, so we get a 1 here and a 4 there. Okay? So now we multiply across. I'm not worried about sign right now. 8 times 4, 32. 1 times 11, 11. A negative fraction times a negative fraction is actually positive. So I'm going to leave this final answer positive, right? The only thing we want to have to try to do at the end is divide or reduce. 11 does not go into 32. If it was a 33, it would be okay. And does not reduce either. So that's our final answer. Now, if you wanted to, you could make that a mixed number. But a lot of times in algebra, we leave answers as fractions in lowest terms because you could do a lot more with fractions. You do a lot more operations with fractions. Okay? You might have heard the term improper fraction for that, but we just call them really fractions in algebra because, again, we do more with fractions. We can do more operations. So that's our final answer, 32 over 11. Now, the other exception to that would be if we need to make them fractions. So before we flip the second fraction and multiply for a problem like this, we have number 4. And since it looks like we're working with some type of fractions here, we're going to make this 4 over 1. So we got to make everything into a fraction first if we know we're working with fractions, or going to be working with fractions eventually. So before I change the sign here, I'll still keep it division. We're going to make this mixed number into a fraction first. So we multiply and add. So 7 times 1 is 7, plus 3 is 10. So that becomes 10 over 7. Okay? And now we can keep it negative. You don't worry about your sign until after you multiply and add. So now we have 4 over 1 divided by negative 10 over 7. And now we can make a multiplication. So 4 over 1 times, flip this second fraction and multiply, 7 over 10, or negative 7 over 10. Okay? So now we look to reduce vertically and diagonally. We can't reduce this way, right? But we can reduce, let me just make that multiplication sign a little bigger. We can reduce 4 and 10. So if we look this way, well, 2 goes into both of those. So 4 divided by 2 is 2. 10 divided by 2 is 5. Now let's multiply across. 2 times 7, 14. 1 times 5, 5. Remember, a positive fraction times a negative fraction makes our final answer negative. Okay? If we'll do one more example just to make sure you got this down, and I want you to try this in your notebook on your own. Okay? Again, so go ahead, pause the video after you copy this down. Try this problem on your own. And then after you complete it, restart the video and see what you got. Okay, the next 30 seconds are going to be blank. Okay, so hopefully you got the trash problem on your own. So we're dividing, and there's no integers or mixed numbers, so we don't have to worry about making anything to a fraction. So we make it a multiplication problem by flipping our second fraction. We're taking the reciprocal of the second fraction and making it multiplication. Now we look to reduce vertically and diagonally. Nothing vertically, but diagonally the 5s can become 1s, because 5 goes into both of those. 2 goes into 6 3 times. 2 goes into 16 8 times. Now we can multiply straight across. 1 times 3 is 3. 8 times 1, 8. And now I'll worry about my sign. A negative fraction divided by a positive fraction makes our final answer negative. Okay? So final answer is negative 3/8. Thank you very much for your attention, guys. Hopefully you found this video lesson helpful. If you have any questions, please let me know. There's a cool sign to finish up. Math, just do it, right? So some people love math and some people don't, but if you want to get better in math, you just got to do it and work through it. And the more you do it, the more you're going to get better with it, and the more you're going to enjoy it and gain more confidence with it. So I kind of like that. That I don't want to say that imitation of the Nike symbol. Math, just do it. All right. So thank you very much for your attention, guys. Have a fantastic day.